So, the Messier catalog is a collection of objects in space that are not stars, basically. They're things that we can see most with the naked eye. Some are much better with binoculars and or a telescope, but most of these are things that we can see just with our naked eye. And a guy in France named Charles Messier was basically looking for comets. Was coming across things in the sky that were not comets, but they were also not stars. And so he started to write these objects down to keep track of where they were. So because of the small telescopes at the time, these objects are some of the biggest and brightest ones that we could see. And they're really popular to be able to look for and photograph even today. And these were things that we could see in the sky, and we originally just thought they were stars. Then, upon closer inspection, found out that they are not. So, the Messier catalog is a collection of 110 of oh my gosh, a collection of 110 star clusters, nebula, and galaxies. So the first type of Messier object is called a cluster, and there's two different categories of clusters of stars. We have what's called an open star cluster, and these are going to be just that. When you look at them, they don't at first glance necessarily look like a group of stars, but when we inspect them closer, we can definitely see that they are a group in the same general location in space. So they don't just appear to be in the same place in space, they are in the same place in space. These are usually fewer stars, maybe just a few hundred. So remember in astronomy, when we say fewer, we're still talking on the order of hundreds and thousands. And then globular clusters are much more obvious. These are usually they look kind of like a big ball of stars in space. They're very densely packed, there's a lot of stars, and they're kind of bound together by gravity. So this is the butterfly cluster. This is M6. This is an open cluster. Now, what we find in astronomy is we name things in a very descriptive way, typically, and not necessarily anything to do with science. So if you turn your head and you squint, you can definitely see a butterfly shape. With that nebulosity, you can see that blue dust and gas. Probably might still be some stars forming there. It's hard to say without looking that up. But you can see that there's relatively very few stars, and at first glance, you might even just think that they just look like they're in the same place in space, but in reality, they're in the same. So this is the butterfly cluster. This is an open cluster. Same thing with the heart-shaped cluster. This is M50. This is an open cluster, but these stars here in the center, these are all geographically close to each other in space. Oh, and all of these blue stars are a part of that heart-shaped cluster. This is a globular cluster. And so you can see the Great Hercules cluster, M13. This is what you would think of when you think of a cluster. It's a bundle of stars. They're all kind of close together, very densely packed. And from a distance, that would definitely look like a single point of light. But as we get closer, we can see that it's not. Same with the thing with M4, globular cluster, lots of stars. Like all these little tiny stars that look similar, those are a part of that globular cluster. Nebulas we've talked about. Nebula is a place where stars are being formed. Lots of dust and gas in space. And so that dust and gas comes together to start forming stars. And a lot of times you get many stars out of the same nebula. Now, planetary nebula is put into this category because these are some things that we can see in the sky, but it's very misnamed. There's no planet, and it's not a nebula, but they look kind of similar. We'll talk about these a little bit more when we talk about stellar remnants. But basically, a nebula is where stars are being formed. A planetary nebula is a dead star. So the star has stopped fusing, and it's what's left. Either way, they're very beautiful. This is the Eagle Nebula. This is one that you've probably seen pictures of before. If you look closely here in the middle, you can see this kind of jet of dust and gas coming across. That is the picture of the pillars of creation. And this is a Hubble image, as most of these pictures are. This is M16. And this is where we can watch stars being formed. And this is huge. Like, this is light years across. This is a giant place in space. But this is one of the more famous pictures in astronomy. And this, I think it was taken in the early mid 90s by the Hubble. And this just gave us an enlarged view of the center of this nebula. It's just really, really gorgeous. I love this picture. So this picture on the left is the Hubble picture. So Hubble is a visible light camera. So the wavelengths that our eyes can perceive, that's the pictures that the Hubble is taking. The picture on the right is an updated version with the James Webb Space Telescope. This is a fairly new telescope that was launched here a few years ago, and it's taking some just incredible pictures of our universe. So it's much larger than the Hubble. Do not want to discredit Hubble at all. Hubble is a very special place in my heart. I love the Hubble site. Go visit it. Gorgeous pictures. But he is getting kind of old. He's lasted longer than we thought he would. And so Hubble is a visible light picture. James Webb takes more on the infrared side. So its wavelengths are shifted to, it's a different type of camera. It's more of a thermal camera than it is a visible light camera. And so when it takes pictures, it's taking pictures of something else than what the Hubble is. So we're getting a lot of different information. It is also much larger, so it's taking a lot more detailed pictures. So I want to talk a little bit about false color pictures in astronomy. So before I continue, I'm just going to add a little note of warning. Most astronomical images do not show the natural colors of the object that they're taking a picture of. For example, the Eagle Nebula is made up of hydrogen gas. So that's what most nebulas are. And so when that hydrogen gas is heated, it glows red. So to help improve the color contrast in these images, what we do is we enhance the colors by taking 3 different pictures of the nebula through a filter. So these filters only let a specific wavelength pass through them. So in the case of this Eagle Nebula picture, we have a filter for near infrared, red, and green. And what we do then is we color that infrared, red, and green, red, green, and blue. So we take those pictures and we color them in the red, green, and blue. And then when we put them together, that's going to give us the pictures that we see. So when we say false color, what we've done is we have enhanced the colors so that we can see them better. It's not that this isn't what we're actually seeing. It's just that we've taken those colors and we've seen them. We do this for visible light pictures, but we also have to do that if we take an X-ray picture because we can't see X-rays. We can't see ultraviolet. We can't see radio waves. So we have to color enhance them in some way in order for us to interpret those wavelengths in a visual way. So this is the Lagoon Nebula. This is M8. I really like pictures, as you know. You can see all of this dust and gas. It would look very fuzzy it does look very fuzzy in the sky. The Orion Nebula is probably one of the more famous ones. This is probably one that if you're going to take a picture of the nebula, this is where you're going to start. This is a lot of times considered Orion's sword. It's right next to his belt. So M42 is a very, very famous one. There's lots of pictures of M42 out there. The Ring Nebula is an example of a planetary nebula. So again, you can kind of see the difference. The inside of these nebulas are dusty, for lack of a better word. You can kind of see where this star has died. This is the Ring Nebula. So this star, I believe it's probably this one, is the dead star. So it has stopped fusing hydrogen and its outer layers have just kind of blown off. And they're still really hot, and so they're glowing. And so this outside area is the nebula part. So it's not really a nebula because it's not fusing stars, and that's not a planet. That's just a dead star. This is the Dumbbell Nebula. Again, we're enhancing these colors, but very beautiful in the sky. This is a planetary nebula. You can kind of tell the difference because there's not, you can see how clear it is in the center. The Crab Nebula is a supernova remnant. This is M1. This is the first one. And then we have galaxies. So galaxies are collections of millions and billions of stars. We live in the Milky Way galaxy. We've looked at it a little bit. We watched that video the other day. It showed us where we were. We live in the Orion arm of the Milky Way galaxy. And we'll look at the Hubble Deep Field in a minute, but there are hundreds of billions of galaxies in the universe. And every galaxy has hundreds of billions of stars. And we have an estimate that most of those stars all have a planet. So there's a lot of stuff out there. So there's three different types of galaxies. The spiral galaxy, which is what the Milky Way is, has those arms kind of curving out. So there's like columns of stars that are coming out and curving around the center. So this is a rotating disk. I'm trying to blank on which one this is at the moment. Elliptical galaxies are more oval disks, so they have more of a definite shape to them. They look just kind of look a lot like a globular cluster. But their motion is more chaotic, and there's definitely a center where it's rotating around. And then we have irregular galaxies, which don't really fall into the category of spiral or elliptical. We just call them irregular. This is M74. Again, beautiful pictures. Again, this is a Hubble picture. And when we look at the Pinwheel Galaxy, this is one we see a lot on posters because it's just beautiful. Lots of different colors that we've enhanced with this one. This is M101. This is a spiral galaxy. You can see these arms coming out from the center, these lanes of stars. The Sombrero Galaxy is kind of unique because it sits on its side from our perspective. So we are looking at it from the side as opposed to on the flat. A lot of things, solar systems typically tend to be in flat planes like this as well. We'll talk about that when we talk about our solar system a little bit. M87 is an elliptical galaxy, so you can see there's less, I guess more, I don't know if it's more or less structure. It's more of a circular shape. Looking at this particular picture, it looks like just one point of light, but there's billions of stars in that little point there. M49 is the same way, very circular structure to it. The Saccaro Galaxy is just this weird thing that just has stars doing what they want. M82 is an irregular galaxy. So you've seen a picture of the Hubble Deep Field. Basically what we did is we took the Hubble and we pointed it at a very dark part of the sky. So if you've been out to look at the Big Dipper or the North Star, Polaris, there's this part of the sky is just not very bright. There's not very many bright things. And so astronomers did what they do and they said, let's take a picture of that spot. And so they pointed the Hubble at this spot in the sky, this little red X. And they pointed the Hubble at the sky for 11 days. Now this took something like 80 orbits. So the Hubble is orbiting the Earth. We get something like 14 or 18, I think it's 14 orbits a day. And so for 11 days, we pointed the Hubble at that point in the sky and we took a picture. And that's what we got as the Hubble Deep Field. Now we've talked about this a little bit. Almost every single thing that we see in this is a galaxy. Now this is a star, and I believe these two really bright things are stars that are just in the way of that. There are some stars there. But everything in there is a galaxy. A galaxy, not a star, but a galaxy. We can see some of those structures. We can see, this is a spiral one. We can see it down here in the bottom. And this just completely changed our view of the universe. Like, holy cow, There's so much out there. I'm gonna, whoops. We watch these in class. I'll put a link in Classroom for you to watch those if you want. So now we're zooming in on some of these. We're using the James Webb to zoom in on some of those parts. The James Webb can take the same, relatively the same image in like zero point 0.8 days. So instead of 11 days of taking that picture, James Webb can do it in zero point 0.8. So they did kind of a comparison test when they launched James Webb. It's one of the first things that they did. And we ended up with an incredibly gorgeous picture. And so those are galaxies. And there's a lot of them out there. Um, and those are Messier objects. So those things that you're looking at in the sky that are not stars, but are points of light that we can see that are not just a single point of light. We have those clusters, we have the nebula, and we have the galaxies.